Hello, welcome to the small presentation about one of the design patterns, the software design patterns. It's called chain of responsibility. And in this design pattern, first of all, it's one of the behavioral design patterns. We know design patterns are or have three different categories: the structural, behavioral, and creator design patterns. So this one is from the behavioral ones, and in this design patterns what happened is that an object or a sender object send a request to some of the receivers, which we called like handlers, and this request goes in a chain, as we can see in this picture. It's like a chain, and every one or every person of this image sends the request to another one, and this is actually happens when the first person failed to handle this request, so it passes it to the next one. So let's see what does the chain of responsibility consists of. It actually consists of two main things. We have our client or the sender of the request, and we call this a source of command object. So it's a sender or a source of command, and also we have a series of receivers, and these receivers we called it processing objects, or we can call it receiver. So let's go for more easier naming conventions. Let's call this commands as a sender and the processing object as receivers from now and then. So how the chain of responsibility actually works. In this model or this design pattern, the processing or the receiver object detects the type of the command at the runtime, and based on it, it will delegate it to the receiver that can handle the task. But it goes as in sequence. So here the sender sends its request to the first receiver, and if the first receiver was successful enough to handle this request, it will exit immediately and solve our problem. Return us the result. If not, it will send or transmit this request to the next receiver in this chain, which is receiver 2, and that's why we call this design pattern the chain of responsibility, because receiver 1 delegates the responsibility of handling this request to the receiver 2 or to the next receiver. And again, if receiver 2 was successful to handle the request, it will exit with the solution. If not, it will delegate this request to the next receiver, and so on so far. So as you have realized, I'm saying a lot of if, not if else. So this model actually comes here to solve the problem of if else conditions. So if we have a lot of action condition blocks in our system, it's very recommended to use such design patterns, because as we will see later, it has a lot of advantage to use such model instead of the conventional if else loops. Let's go here, and the thing that I also want to mention here, this is the object-oriented version of the action condition blocks. So why? One of the main advantage of this pattern is that it's very flexible, so it has a lot of extensibility, and we can easily add a lot of different receivers in the future. So supposedly we have changing in the plan, or we have new module we want, or we want to implement. We can easily add receiver 4, receiver 5, and so far. And not only this, we can also rearrange this receiver. We can bring receiver 5 over receiver 3, receiver 6 over receiver 1. We can also reconfigure them if we want. And the other thing of the advantage is that it is loosely coupled. This design pattern implements the idea of loose coupling. How? That in this design patterns, the sender class is not related, or it's not connected to a specific receiver. As we will see later, we will not make this sender class send its request to a single receiver. We will send it to a chain of receiver, and the one that can handle the request, it will give us the answer. The other thing that why it's loosely coupled, because as we know, if the decision will be taken in the runtime, this is an exact implementation of the loose coupling. I also want to mention that it's very similar to the decorator design pattern. However, in the decorator design pattern, all the receivers will handle the request, but here in that chain of responsibility design pattern, only one receiver will handle the request. Let's go here. So as I said before, when to use this design pattern, if we have a lot of if-else's in our system, or if we have a specific sequence of procedures that needs to be followed. Imagine like a pipeline. If you have a pipeline that needs to be passed through different stages, so it's better to use this design pattern. And here we show the class, the UML class diagram on the left and the sequence diagram on the right. So in the left picture we have the sender, and this sender sends its request that gets handled here, and this is actually an interface. And here we have classes that implements this interface. We have these classes which are receivers, have receiver 1, 2, 3, handling such request from a sender. And in the sequence diagram, as we might have showed here, same idea. The request goes in a series of receivers to be handled. So let's now transfer to the code and see these things in action. Here we have our interface. I've called it chain. So this is our interface, and it has two functions. The first one, it's called the setNext function, takes an object of type chain. We will be using this in the main in order to decide which receiver going to be the next chain. So here we can reconfigure, we can rearrange our receivers, and we will see this in the main later. And the second and last function here is a calculate. I call it calculate, and it takes the request, and this request of type numbers. And here I have created the class numbers. So in my numbers, in this project I'm doing just very simple mathematical calculations. I'm doing like a class that should add some numbers together, another class should subtract numbers, another class will multiply these two numbers. So based on two given numbers, and a string, which is like a command, the needed calculation. For example, add, this will be like an add or subtract or multiply. Based on these three inputs here, in the runtime, this program should decide what I am going to do, which receiver gonna handle this request. So if I'm passing, for example, here in the needed calculation, the string, if I'm passing the word add, it should add. So it should delegate this this send or this message to the class here that adds a number. If I said subtract, it should go to the subtract receiver. If I said multiply, it should go to the multiplication receiver. So let's do this again. We have this public int number 1, number 2, and the string need calculation. And here I'm having my constructor takes these three parameters and I'm setting them here. So let's move to the add number class. In this class here I'm implementing my interface. So, and I'm creating this property here, and we have next in chain. I've called next in chain, and I'm setting this here. I'm giving this chain, this next in chain will be equals next chain. So this property actually is made to store the next object in this chain that can perform a specific mathematical operation, as we said before. And here I'm implementing my second method that I've called it calculate, which takes a request of type numbers. And I'm saying here if the request dot needed calculation, which is my property here, sorry, my needed calculation, I'm saying if this string was equal to add, if I have passed the word add, then you should console.writeLine number 1 plus number 2, it will show number 1 plus number 2 equals, and this is the mathematical calculation will be here. So if I've passed, for example, 1 and here 2, it should say 1 plus 2 equals to 3. Else this object here dot calculate request next in chain dot calculate request in order to move to the next chain. So here if I couldn't resolve if the receiver 1 here, the addition receiver, could not handle this request, then move to the next receiver, which is subtract. So in the subtract, it's the same code here, except for I'm passing the word sub, and here it's the hyphen or the negative, and here I'm subtracting the two values. And again, if you failed, move to the next chain. And here is my last chain. As for now, it's my last chain, and doing the same, pretty much the same code, except for here the word multiplication I'm passing, and I'm doing the multiplication operator. Else, so basically if I don't have another class here, so I shouldn't say this, and I should say else, maybe just console.writeLine maybe like only works for add sub and mul. And here's our program. So in the main, I'm creating an object from the different mathematical operation. These objects will be my receiver chains, the receiver objects. So I have an object from chain calc add. I call it chain calc add. This is from the add number class, and also a chain of the subtract from the subtract numbers class, and from the multiplication also class. And here I'm actually configuring my chain. Here I'm putting the first so here I've created the chains. Here I'm joining the chains, I'm connecting my chains. Here I'm saying that this is the first chain, this is the second chain, this is the third chain. So I'm drawing my flow, my control flow here. So here I've said chain calc chain dot set next chain, and I'm passing the chain calc subtraction. So here I've said that the addition stage will be the first. Go to the addition receiver. If you can't do this, in other words, if you didn't find the word add, the string add, so you should go to the next change, and I set it to be the subtract. Of course I might have said the mul, but let's suppose my business said that the next receiver should be the subtraction stage. And then again I'm setting that after the subtraction, if it fails, it should goes to the next chain, which is multiplication. Okay, so and here in the last thing, I'm just defining the numbers, the object, which is the sender object, and I'm saying I have a request of type numbers equal new number, and I'm giving it the first number is 10, the second is 5, and I've passed the word add this time. And let's make my program do the calculation by saying chain calc add.calc request, and let's start the program. So the program now detected that I've passed the word add, so it gives me 10 plus 5 equals to 15. Okay, so let's change the keyword to sub, and let's try what will happen. So the flow went like that. It went first to the chain calc add, and it searched for the keyword add. It didn't find it, so it sent or delegate the message to the other chain, or the request to the other chain, which was a sub. The subtract numbers class have found the word that it was waiting for, the sub, so it could handle this request and bring us the result, which is 10 minus 5 equals to 5. Okay, so let's try mul. So no need to go to the mul now because I found the sub, but now if I just say mul, here it didn't find it in the first receiver, didn't find the add, the second receiver didn't find the sub, the third receiver eventually finds a mul, so it had done the multiplication. What if I've passed, for example, blah blah blah, and here, so it gives me that else condition and the multiplication number, my last chain, which is only works for add, sub, and mul. And now let's suppose that there is a change in my program and I want to implement a new operation, for example the division operation. What should I do? Should I go to the code that had a lot of if else's and go inside the code and change it, which will evaluate the which will violate, the open closed principle? So of course not. So this is the best way to use this design pattern. So I only need to add new class, and I'm calling it division numbers. Okay, and of course I'm going to implement the interface chain, and or let's just get this copy and paste because it will be much easier. And I only need to make this as div, and this will be like that, and I'll be making the division, and I'm change this to go to the next. I'm taking this and submal, and now I have a new feature that I can do the division. Okay, and that's what all I need to do. I didn't need to get inside this logic or this logic. It was left closed. It was closed for modification, but I could have make it extensible and add a new feature. So after I've just created my division class and modified the last chain in order to accept the next chains, and just need to go to my program, to my main, and just create a new object of the division class. Let's call this chain calc div, which equals to division numbers. Okay, and now I've created the chain. I need to do the linking. I need to link it where I will put this div. Of course I can put it before this. So this is the thing that I said in the slide. I can rearrange the receiver and configure them as I want. So now I'm saying that if the mul failed to handle the request, pass it to the div. Okay, and now let's try our program with the div. Let's see if it works or not. Hopefully it will. And yeah, it gave us 10 over 5 equals to 2. So this was a pretty simple example to demonstrate how the receiver works in sequence, how this chain of responsibility is working, and how the responsibility is transmitting over the different receiver until it gets solved eventually at one of them. Now we have our last point here. Where is our chain of responsibility pattern in the .NET? So actually the ASP.NET is a very good example of it. And we know we have the ASP pipeline, the middlewares that we have. So in the ASP.NET, every request in the pipeline passes through a series of modules that implement these modules implement the HTTP module before it reaches to the target handler that implement the HTTP handler. So going in this pipeline, once the module has done its duty, it passes the responsibility of the request to the next module, and so on so far until reaching to the handler. So this was pretty much everything I wanted to say about the responsibility and the chain of responsibility design pattern, and thank you so much.